Dear children, this is the fourth lesson, comes under competency level 2.3. Use different techniques to separate mixtures. This video discusses the different separation techniques that can be used to separate constituents from homogeneous mixtures. In this video clip, hope to discuss about another method of separation techniques called distillation. As there are many distillation methods, here explains the simple distillation and the fractional distillation. Let's understand what is distillation. It is a chemical process to separate compounds from mixtures. These mixtures should be made out of two or more liquids with different boiling points. Here I have mentioned different boiling points. Now you can remember that I have mentioned the factors considered when selecting a method for homogeneous mixtures are the boiling points and the melting points of the constituents. In this process, we have to heat until one of the components boil. That is the basic of all distillation methods. Here it is given there are different types of distillation methods as simple distillation, fractional distillation and steam distillation. Before move to the topic, we have to identify the main apparatus used in distillation process. This is called Liebig condenser. Liebig condenser is a very simple condenser but having two specific features. Here you can see two outlets. One is for provide water, the other one is for to remove the water inside the condenser. In between there you can see a tube. Surround the tube there is this outer covering circulate this water. So this is called Liebig condenser. Now let's see how this Liebig condenser is fixed in a distillation process. So what here actually this one is little bit complex because here it is mentioning as fractionating column that comes later on. Now you have to put your attention here, water in and water out. What is the reason for fixing water outlet on the top and inlet at the bottom? Think, you have to think. I will give you a clue. When you provide water from this end, what will happen to the water flow? Will it remain more time in this condenser or will it just flow through this? Yes, you can understand. If you insert or if you fix this part, this side, this upper end to the tap, what will happen? The water goes through the condenser very fast and will remove from here. What do you think if we put the water inlet here? Then it should be pressurized towards the upward. So then you can understand this water will slowly circulate around the condenser and goes out. Okay. Now look at the diagram here and now you understood what is the reason for fixing water inlet and water outlet here. So that is the speciality of this condenser. Now let's move on to again I would like to pay your attention here again. Here in this round bottom flask you have to put the mixture that you want to distill or to separate the constituent. And here you using the Bunsen burner, you provide heat. What will happen here? The mixture, the things inside this round bottom flask starts to boil and produce vapor. That vapor goes through the fractionating column or this column. If this is not here, we can fix this liquid condenser directly to this, and this will go through to this conical flask. Remember now, here steam goes out. Now what will happen? This steam will condense due to the cool inside the condenser and comes out as a liquid form. Keep that principle in your mind. Simply, here this is the simple distillation method. This can be used to separate the components mixed with volatile substance and non-volatile substances. In this method, only volatile components can be separated. Volatile, I hope all of you can understand what is volatile. It easily comes to its boiling point and vaporize. So, here, preparation of drinking water from seawater and purify well water from other dissolved salts can be done through using this simple distillation. What is the science behind this? When well water is subjected to heating, only water gets vaporized. Salts do not vaporize but remain at the bottom. So we can get very pure and clean water by using this simple distillation method. This is the way that the apparatus fixed to get obtain distilled water. Here you can see this round bottom flask halfway filled with salt water and providing heat. What will happen? And also the other end fixed to the liquid condenser and to the conical flask. What is happening here? When just say this is salt water, seawater. So when you provide the heat, what will happen? Water will evaporate. Water comes to boiling point and remove as water vapor. This water vapor stuck in the rooftop. And this vapor goes through the condenser and comes out as pure water. This is how distilled water is obtained from seawater. Now look at this. What is this? The same phenomenon. The same science is here. Some countries use this very simple solar distillation unit to purify water from seawater. This is, you can understand it. There is a specially constructed roof here, and this is a salt water tank filled with salt water here upper part, and a small drains, two drains, an outlet here. What will happen when during daytime this salt water get heated and water vaporized and condensed near the roof. Actually, when water vapor stuck on the roof, getting cooled and come along this rooftop and collected to these two drains, and we can remove the distilled water from here. This is a very simple, cost-effective method. You can see that we no need to provide any electricity or any energy to heat the salt water. So, but the problem is we can get limited amount of water, but in some countries like Argentina use this method to purify water for their get water for their army. However, when it comes to fractional distillation, it is bit complex and have to control some conditions. Remember, the principle behind is same. Here we use a fractionating column and Liebig condenser. Here also, when there is many volatile components mixed together, we cannot use the simple distillation method. In the simple distillation method, we did not control the boiling points of other components. Here we have to control the boiling points of the constituents. So cannot use the simple Liebig condenser only. So we have to use a fractionating column. The mixed volatile components must have considerable differences in their boiling points. That is another important point. That means the components in the mixture should have different boiling points, and the difference between each of them should have a considerable difference. So then components can be separated by collecting the vapor at different temperatures and condensing them later. Here we have to provide controlled cooling conditions according to the boiling points of the different constituents. If you want to separate alcohol from water, we can use this method easily, because the boiling point of water is 100 while the ethanol having 78, so that the difference between the two boiling points is 22 degrees centigrade, that is less than 40. So we can use this method. Fractional distillation is done in large scales to separate different fuel from crude oil. So this is used to separate crude oil. Crude oil consists with many different hydrocarbons. Hydrocarbon are chemical compounds consist with hydrogen and carbon atoms. So I won't explain much about these hydrocarbons because we have to stick to the topic. And let's discuss the steps involved here. First, we have to vaporize the crude oil here. Then this vapor is sent through the fractionating column. This is the rough diagram of the fractionating column. But if you look at the actual crude oil extraction, this kind of huge fractionating columns are there. So within this column, what will happen? The temperatures at different heights get different values. So here gets the highest temperature and upper part get less. So then it is clear that from the top you can get low volatile compounds and they are having very low boiling points. Now tell me which, so then now I have already said that, so that at the bottom you can get the compounds of high boiling points and they are not very volatile, so they remain in this lower part. So here if you go through these components given here, you can find out that their boiling points is less towards the upper part. We can use this method to separate the components of the atmospheric gases also. In this situation, first liquidize the air and then separate oxygen and nitrogen separately. Here this is the fractional distillation of crude oil. Here distillation of crude oil is a mixture of many hydrocarbons. Temperature is controlled at different heights and the components are withdrawn at the respective positions. The components of low boiling points are collected at upper part and the high are from the lower part. Here you can, if you go through this, you can find out that kerosene oil you can taken from somewhere in the middle. diesel towards the bottom, and here gasoline, LP gas like components from upper parts. So now we came to the end of the video. So thank you very much to watching this. Hope to meet you with my next video, that is the first lesson of steam distillation method.